to look inside it. At a depth of about 70 kilometers, a part of the Earth begins which is called the mantle. Deeper, up to 2,890 kilometers, this layer reaches the core of the Earth and contains approximately 80% of the entire volume of our planet. The deeper, the hotter the mantle becomes, from 200 degrees Celsius at the Earth's crust and up to 4,000 degrees at the core. These are quadrillion tons of hot, molten, circulating rock and minerals called magma. Lithospheric plates move due to the movement of heat in magma from the core to the Earth's crust. By their movement, they create mountains and depressions, cause earthquakes. In some places, called magma plumes, hot magma moves to the Earth's surface in relatively small streams or jets, accumulating in the crust if it does not find an easy way to surface. This leads to the formation of magma chambers and calderas, which will form the basis for the emergence of volcanoes and supervolcanoes. So what could happen if millions of tons of hot molten magma did reach the Earth's surface? Let's take a look at two very famous volcanic eruptions. It'll focus on the eruption of the Krakatoa volcano in 1883 and Tambora in 1815. Both of these volcanoes are located in the region of Indonesia, but their eruption has led to consequences across the globe. To understand the strength or danger of any eruption, volcanologists use the VEI scale, the scale of volcanic activity. It's estimated by the volume of eruption products thrown onto the surface, the so-called tephra, and is counted in cubic meters. The eruption of Krakatoa, which claimed the lives of about 36,000 people, caused a 46-meter tsunami, as well as a global cooling of 0.4 degrees Celsius, is estimated at 6 points on the VEI, with the release of tephra up to 10 cubic kilometers. This eruption is equivalent to about 1,000 nuclear bombs, 200 kilotons each, detonated at once. The eruption of Tambora reached 7 on the scale of volcanic activity, which means the volume of ejected tephra is up to 100 cubic kilometers. Taking the lives of 76,000 people, it provoked an even stronger cooling on the Earth's surface by 5 degrees Celsius in some areas. This led to a year without summer, where snow fell even in June in Canada. Hunger in Europe and Asia due to crop failure, acid rain and dry fog in the northwestern United States. And this is only part of the consequences we know. But we're still too far from the complete destruction of humanity. We'd need volcanic super eruptions reaching 8 points. Super eruptions are catastrophically gigantic discharges of magma rocks, ash, and aerosols into the atmosphere. Super eruptions with a volume of thousands of cubic kilometers occur very rarely, and volcanoes and caldera systems that produce them are colloquially called supervolcanoes. The most famous supervolcano is in North America, in the state of Wyoming, the Yellowstone National Park. The Yellowstone caldera, slowly moving northeastward following the lithospheric plate, has already erupted 3 times over the course of 2.1 million years. Each of these super eruptions led to a global climate change. Our entire total nuclear reserve does not even come close to comparing with such a destructive force of the Earth's nature, in terms of the amount of energy in TNT equivalent. About 630,000 years BC, one of these eruptions led to the formation of a caldera 70 kilometers in diameter. The volume of ejected tephra has reached about 2,500 square kilometers, the consequence of which was the abundant ashfall and the formation of Huckleberry Ridge tuff, a layer of volcanic material that's found throughout almost the entire western United States. For comparison, if we take all this volume of hot ash, magma, volcanic rocks, and stuff it into a cube, we get a structure 13 kilometers high, which is almost 1.5 times higher than Everest. If we hypothetically assume that Yellowstone will once again have a super eruption with a volume of ash and solid rocks of 330 cubic kilometers, will this be the end of humanity? This time, we're talking about a cube as high as Mount Kilimanjaro. Using a tephra sediment map, we can see that the ash will spread to almost the entire continental United States and parts of Canada. Everything in the states adjacent to Yellowstone is likely to be completely destroyed in the first hours of the eruption. In the very same Yellowstone National Park, which is about 64 kilometers in diameter, lava, magma, and other products of the eruption will reach a meter in height. A super eruption of this magnitude will cause an almost complete collapse of the North American agro-industry. A cloud of ash will block sunlight from reaching farmlands in the central and eastern United States. Acid rain and tephra will destroy crops, pollute water sources, and kill livestock. In addition to the ashfall, the new super eruption will produce a large number of volcanic bombs, which are the magma itself ejected from the volcano at great speed. These bombs will destroy roads, houses, and communications in the area up to 150 kilometers from Yellowstone. The number of deaths, the total consequences for the whole world, are difficult to calculate. A catastrophe of this magnitude will be possible to compare with the fall of an asteroid several kilometers wide. It's also likely that for a period of up to several years, North America will feel the full impact of the volcanic winter, and the climate of the entire world will be destabilized. Scientists believe that sudden changes in temperature will lead to anomalous natural phenomena. Hurricanes, tornadoes, and thermal domes will appear. This means damage to farming, not only in the United States, but also around the globe. Crop failures, hunger, droughts, and cold snaps will become the norm for several years. It's important to say that despite the rising and falling seismic activity of Yellowstone, scientists have no fears. This supervolcano will almost likely never be capable of super eruptions, or at least for the next thousands of years. In fact, the super eruption has already almost destroyed humanity, approximately 74,000 years BC. The super eruption of 2,880 cubic kilometers, 8 times larger than in the hypothetical model of the Yellowstone eruption, according to scientists Michael Rampino and Stephen Self, could lead humanity to extinction. We're already talking about the super eruption of the Toba volcano on the island of Sumatra in Indonesia. In a 1992 article, they suggest that this super eruption not only led to a volcanic winter, but also accelerated the glaciation process. This is also associated with a bottleneck in human genetics. Some studies find evidence that in the period from about 100 to 50,000 years BC, human civilization shrank to 10,000 individuals at best. This is evidenced by the low genetic diversity of our ancestors, according to the same Michael Rampino and Stephen Self. Until some time, it was believed that the super eruption of Toba led to a volcanic winter of at least 6 years in Africa and Europe, but recent research actually suggests otherwise. In 2018, the results of a study of the tuff and traces of this super eruption were published, and surprisingly, there is evidence that human activity did not stop, but on the contrary, increased. On the southeast coast of Africa, tools were found in the layers of the earth both before and after the eruption. In addition to small sharpened stones, there were also more complex arrowheads and spearheads. Excavations around Lake Malawi, also in Africa, do not provide any evidence of a catastrophic volcanic winter from a super eruption. Most likely, the effect of ash and aerosols was overestimated and could not lead to a 6-year winter in Africa and proximity to the mankind's extinction. But what if the super eruptions are just part of an even more catastrophic event, which has likely led to the extinction of the dinosaurs along with the asteroid, which has also contributed to this? Only now will we come to an event that's really capable of creating a global hell: volcanic floods. A volcanic flood is an event that does not fit into the scale of volcanic activity because the total emissions of ash, magma and rocks already vary in millions of cubic kilometers. Returning to our comparison with a cube, its height on average reaches space, or 125 kilometers. All this volume of magma and ash pours out over millions of square kilometers, covering them with a giant layer hundreds of meters high. The consequences of this form huge plains, the traps, with a characteristic relief that resembles a staircase. Even if scientists now cannot name the exact reason for the formation of the traps, which cover huge areas in Siberia and India, there is no doubt that this is a large-scale and catastrophic process. Nor is it surprising that the age of the trap's formation roughly coincides with the dates of the largest mass extinctions. One of these led to the extinction of 95% of species of living beings. Unlike super eruptions and asteroid impacts, the impact of a volcanic flood on Earth can last for hundreds of thousands of years. They occur when a plume or a long torch of magma reaches the uppermost layers of the Earth's crust. By comparison, the caldera of the Yellowstone supervolcano is located at a depth of 8,000 meters. Volcanic floods begin with a series of powerful earthquakes and a rise of the surface by several hundred meters. Cracks and ruptures in the uplifted Earth will be accompanied by a series of super eruptions, ejecting tephra and lava in pillars averaging 50 kilometers in height. Magma will slowly melt through the Earth's crust and begin to spread over an area the size of entire countries. In the case of the Siberian traps, which formed about 640,000 years from the beginning of the volcanic flood, we're talking about an area as big as the continental Europe, covered with tephra and magma, hundreds of meters high. This, for example, most likely led to the Permian-Triassic extinction of 250 million years BC. The formation of the Deccan traps led to the Cretaceous-Paleogene extinction 66 million years ago and the death of the dinosaurs. The effect of volcanic floods on the climate is thousands of times greater than that of super eruptions or nuclear war. After most of the magma rock from the plume reaches the surface and spreads, the remaining magma will seek another path, spreading horizontally, reaching coal deposits and other fossils. This alone will lead to a huge emission of carbon dioxide into the atmosphere, which will heat the Earth by an average of 5 degrees. A seemingly small figure means the transformation of most of the Earth's surface into a desert for hundreds of thousands of years. The oceans will turn into a toxic, hot, acidic liquid due to the abundance of carbon dioxide and the activation of methane deposits at the bottom. But, as we can conclude from the fact of our existence, the planet is able to endure such disasters, and more than once. Scientists are sure that for the next hundreds and thousands of years, mankind is unlikely to meet with such cataclysms. What about you? Would you like to observe similar phenomena? We will inform you if the plans of the volcanoes change and such an opportunity arises in the world. In recent years, summer temperatures in Europe have reached over 46 degrees Celsius. It snowed in South Africa, and the temperatures there dropped to -10 degrees Celsius. While some scientists say to prepare for severe heat waves, others predict a new ice age or a sharp cooling period is coming that will last millions of years. Throughout the 4.5 billion years of its existence, the Earth has repeatedly experienced ice ages, and a severe cold may arrive again soon. Will the planet Earth freeze over again? And what does humanity have to worry about? You'll probably be surprised, but an ice age on Earth has already begun. Fortunately, we're not in the middle of one, but instead we're in a geological interval of warmer global average temperature called an interglacial period. And when this ends, the real cold will come. So when will this happen? Researchers are trying to find out by studying previous glacial epochs. An analysis of ice samples drilled from the permafrost of Greenland and Antarctica helps to reveal information about the last 800,000 years. Sediment at the bottom of the oceans allows us to look even further, tens of millions of years back into the Earth's past. And the incredible secrets of climate change hundreds of millions of years ago have been revealed by studying the sediment and rocks. Scientists have found that the first Huronian ice age began about 2.4 billion years ago. At the time, the planet received about 15% less sunlight than it does today. In addition, primitive algae emitted oxygen, which displaced methane, a powerful greenhouse gas in the atmosphere. Then, the Earth froze for nearly 300 million years. But at the equator, there were still areas without permafrost. The next ice age, the Cryogenian, wasn't so mild. This era marked the most severe cold in the history of our planet. It began about 720 million years ago. Even at the equator, temperatures rarely rose above -20 degrees Celsius. -50 degrees Celsius and below became the new norm for the rest of the world. Scientists believe that even the world's seas were frozen to the very bottom. At the poles, dry ice or solid carbon dioxide appeared on top of water ice. From space, the Earth probably looked like a huge snowball. Check out this NASA image taken by the Cassini spacecraft. This is what Saturn's moon, Enceladus, looks like. Its snow-white surface reflects 99% of the sun's light, and scientists think the Earth was just about the same during the Cryogenian period. Only bacteria and algae near a few hot springs survived this ice age. The cold returned again during the Paleozoic era. Called the Andean-Saharan, the Ice Age began about 450 million years ago and lingered for 30 million years. But it was nothing compared to the Cryogenian. 3-kilometer glaciers occasionally rolled up to subtropical latitudes, but in general, the temperature was only slightly colder than today. However, everything ended in disaster called the Great Dying, or the Permian Extinction, the largest mass extinction in the history of the Earth. According to one hypothesis, the thawing of the Earth at the end of this ice age led to the explosion of a so-called methane hydrate bomb. When methane, frozen in the ground, warmed, it hit the atmosphere like a huge fountain, displacing a significant part of the oxygen from the atmosphere. This resulted in unfavorable conditions for life. 70% of terrestrial and 96% of marine life forms went extinct. Scientists are still looking for what causes global cooling. They discovered that a decrease in the activity of solar flares played a huge part in this. As the planet received less heat and light from its star, the Earth's temperature dropped. To test this theory, American physicist Robert Ehrlich created a computer model of solar plasma behavior. It turned out that its fluctuations coincide with the periodicity of glaciation on Earth. The light of the sun is sometimes obscured from us by galactic gas and dust clouds. Our climate is also affected by changes in the Earth's orbit and its axial tilt. This is shown in the astronomical model of ice ages proposed by the Serbian scientist Milutin Milankovic. It calculates fluctuations in the inclination of the Earth's axis under the influence of the Moon's gravity and the other planets of the solar system. Similar events occur every 26,000 and 41,000 years. In addition, changes in the Earth's orbit have a cycle of 93,000 years. Our planet revolves around the Sun in an ellipse, first approaching our star, then moving away from it. The model calculates that the Earth receives 5 to 10% less heat at the maximum distance from the Sun, as well as during the largest axial tilt, combined with minimal solar activity. When this happens, an area of glaciers increases and, like all white surfaces, reflects the sun's rays back into space. This makes our planet even colder, and glaciers start growing in size again. The process continues for millions of years. The Earth is also periodically cooled by volcanic eruptions. Their emissions pollute the atmosphere and trap sunlight. The world ocean absorbs carbon dioxide that warms the atmosphere. Meanwhile, continental plate shifts from mountains and steep mountain ranges can draw carbon dioxide out of the atmosphere. As erosion exposes new rock, it leads to a chemical reaction between minerals on hill slopes and CO2 in the atmosphere, weathering the rock and using carbon dioxide to produce carbonate minerals. According to scientists, a combination of all these factors caused the last ice age. It started about 35 million years ago in the current Cenozoic era. The late Cenozoic ice age is characterized by a frequent alternation of incredibly cold glacial and rather mild interglacial epochs. The Earth has been in this interglacial period called the Holocene epoch for 11,700 years, but the weather during this period can also change. Warm millennia are replaced by cold ones. The last epoch of strong glaciation began about 110,000 years ago and ended 9,700 to 9,600 years ago. After that came the thaw, which replaced the Little Ice Age that lasted between the 14th and 19th century. In terms of average annual temperatures, it was the coldest time in 2,000 years. Researchers associate the Little Ice Age with the slowing down of the Gulf Stream around the year 1300 AD. Due to severe winters with abnormal frosts in Europe, gardens froze, and cold spring rains destroyed vegetables. By 1350 AD, the Great Famine broke out and lasted for 2 decades. By the end of the 19th century, a thaw arrived again, which has lasted to this day. But eras of strong glaciation usually return every 10,000 years, so we're running out of time. And some scientists predict an intense cold in the near future. So how is this possible when temperatures on Earth are only rising? Glaciers are constantly melting, and mankind is actively fighting global warming. We've emitted an incredible amount of greenhouse gases into the atmosphere. So far, this is holding back the advance of glaciers, and yet, according to many scientists, nature will take over. But this may not happen for another 100 or even 1,000 years. However, some scientists think that global warming is actually bringing global cooling one step closer. One model of climate change showed maximum warming of the Arctic Ocean. Freed from ice, water evaporates and falls in the form of snow into the subpolar regions. New glaciers are forming. Scientists believe that in the end, the warm Gulf Stream will not be able to break through their barrier from the Atlantic to the polar seas. Then, the ice sheets will begin to grow rapidly. Whenever this new ice age comes, it'll undoubtedly change the Earth, like what happened during the previous glaciation over 10,000 years ago, when glaciers redrew the landscape of our planet. They compressed many mountains and hills with their weight and destroyed vast areas of soil. Ice sucked water out of the oceans, lowering sea levels. Many rivers transformed into huge valleys and lakes within continents. Land bridges appeared between continents. Canada, Scandinavia, the British Isles, most of northeastern Europe and Russia were under ice sheets several kilometers thick. If such conditions happen in the next ice age, humans will have a rough time. According to some hypotheses, the temperature at the equator would drop by about 10 degrees Celsius, and in the north and south, down to minus 50 degrees Celsius. In vast areas, the cold would destroy crops and lead to a massive famine. A similar thing happened after the eruption of the Toba supervolcano 74,000 years ago. According to researchers, only 2,500 of our ancestors managed to survive the long volcanic winter. The entire global geopolitical order would also be turned upside down. The borders of most countries would change due to lower sea levels. According to scientists, the ocean level would descend by 150 meters. Malaysia and most of the Indonesian islands would be united into a single landmass. Sri Lanka would once again be connected to India by a surface land bridge, and Ethiopia would merge with Yemen. Water bodies would also change dramatically. Perhaps the Mediterranean Sea would be cut off from the global ocean. Not a single port in the world would be able to accept ships because the ocean waters would roll away from those ports. But what would happen to North America and Europe? Imagine if you lived in Florida and California, where the sun shines all the time, and walking out one morning and seeing the landscape of Alaska. Such climatic conditions would even happen in the south of the United States. Almost all grain crops wouldn't survive there, and food supplies would quickly run out. Those lucky enough to find food would perish from the cold because power stations couldn't survive long in such cold and would shut down. Buildings would fall into disrepair and eventually collapse. Huge crowds of people would move south. Australia, New Guinea, Sub-Saharan Africa, and Southeast Asia would continue to have a warm climate suitable for agriculture. There, new islands suitable for life would form within the ocean, and India and Brazil would probably have the status of world superpowers. The temperature climate and the lowering of the ocean levels would give these countries a huge amount of new fertile land. But would they be able to feed billions of refugees? Some experts believe that they wouldn't. Battles over food would begin with residents of countries with a favorable climate. Currently, the situation isn't that scary because over the last centuries, the development of our civilization has literally skyrocketed. If we have mastered space and visited the moon, then why couldn't we cope with the cold? There are already a lot of interesting ideas about how to survive the upcoming ice age. One idea is to add greenhouse gases to the atmosphere to warm up the planet. And chlorofluorocarbons might just be what we need. This mixture is much more efficient than CO2. Systems like fusion energy could also help to keep the Earth warm. They are designed for Arctic conditions and work based on nuclear fusion reactions. Glaciers could also be utilized to generate electricity. A mile-high wall of ice would inevitably begin to melt on hot days, and water falling from a height of 1,500 meters or more can provide tons of energy. Giant hydroelectric power plants on rails would likely run parallel to a mega glacier, with pipes mounted to its top. Turbines would extract energy from the falling water and then distribute it to eco-farms at the base of a glacier. With the help of genetic modification, unique varieties of crops that are resistant to severe cold could be developed. Farmers would have the opportunity to have good harvests. Then it would be easier for people to adapt to life in regions covered with ice. In the end, the Inuit people did it without any benefits of modern civilization. Although many would still move to a warmer climate, the use of intensive technologies in agriculture would make it possible to feed as many people as necessary. However, after all, we may not need all this. A mild ice age is another possibility, or the next ice age could take some other completely new form. Nature can turn a specific region into a giant desert. Scientists say that now a huge amount of greenhouse gases pollute the atmosphere with particles of various substances. These gases don't allow the sun's rays to reach the planet, but instead warm up the atmosphere. When a lot of these substances accumulate, the Earth could become a huge baked Alaska dessert. Cold and icy on the inside, but with a warm outer layer consisting of the atmosphere. Scientists have yet to find out which scenario of the next ice age is most likely. But whatever the case, the entire history of the Earth is a series of cold and warm epochs. Judging by the previous cycles, winter is close, and it depends on our preparation whether humanity can survive an upcoming catastrophe. Many people imagine the end of the world as an asteroid strike that destroyed the dinosaurs, or a nuclear war with the entire arsenal of mankind. But what if all this is not even close to what could turn the planet into a hot hell? Space is full of diverse objects we don't know much about. That's why they capture our interest every time we spot them. But with this thrill often comes fear, especially whenever there's a comet heading towards us. It's no surprise we haven't got a clue on how to stop an asteroid or comet from hitting the planet. But soon, having such technology might become vital. New scientists operating one of the most advanced astro cameras have just made an eye-opening finding. They detected a monster comet that's already in our solar system, and it's moving fast. In August of 2013, scientists launched a project to map a portion of the southern sky, which completed in 2019. It's called the Dark Energy Survey. An incredible 570 megapixel camera called the Dark Energy Camera grabbed data from over 300 million galaxies amounting to 50 million megabytes. Scientists have just begun to go over that data, and they found something that they didn't expect. Data created 32 images showing a blurry dot in the darkness of space, located about 2.5 billion miles away from Earth. It wasn't until it got close to the planet Uranus that astronomers were finally able to figure out what this strange object was. What scientists detected was a comet with a size 1,000 times above average. It was dubbed C2014 UN271, also known as Bernoulli-Bernstein, after its discoverers. Given the amount of sunlight it reflects, astronomers speculate the object's diameter is somewhere in between 60 to 125 miles. That's an insanely big number. To compare, an asteroid that wiped dinosaurs out of existence is thought to have been just around 6 to 9 miles wide. But since Bernoulli-Bernstein is still so far away, it's not clear whether the calculations are close to real measurements. Another fascinating fact about this comet is that the last time it entered our solar system was 3 million years ago. That's about the same time a well-known human ancestor, Lucy, lived. Given such a long orbital period, it seems the comet should have come from a very distant place. And it happens there's just such a place, believed to be home to trillions of comets. It's a place called Oort cloud, a spherically shaped region of space containing various remnants from the early ages of our solar system. The Oort cloud is located far beyond the dwarf planet Pluto, and might stretch to 10,000 AU from our star. So scientists think Bernoulli-Bernstein is the most remote comet we've successfully spotted on its way to us. Such an early discovery gives us plenty of time to study this comet and eventually explain its nature. So when will it get close to us? According to scientific estimates, the closest encounter with the Bernoulli-Bernstein comet will come in 2031. So far, astronomers claim the comet imposes no threat, as it will fly by at a significant distance from us. The closest it will get is 11 astronomical units. That's about 10 times farther away from the Sun than the Earth. It won't even be visible in the sky with the naked eye. But since comets' behavior is hardly predictable, we don't know what to expect. Unlike Bernoulli-Bernstein, certain celestial objects will get much closer to us, and a lot sooner. One of such space guests is a killer asteroid that will fly by within less than 0.07 AU. In just about a year, a binary asteroid named Didymos, accompanied by the smaller Didymoon, will make a near-Earth approach. The bigger asteroid is roughly 780 meters in diameter, while the smaller one is just about 160 meters. However, that's more than enough to make a crater that's 6 miles wide and demolish entire cities. Even space rocks that are 500 feet wide are capable of exploding with the energy equal to a nuclear bomb. A meteor, a tiny piece of an asteroid or a comet that exploded over Chelyabinsk, Russia, created a massive shockwave. As a result, tons of buildings were damaged and roughly 1,500 people were injured. And it was only about 65 feet wide. But data concerning asteroid impacts has become even more disturbing. NASA has recently conducted an experiment that proved we wouldn't be able to do anything about an asteroid heading straight towards us, even if we had 6 months warning. The simulation of the hypothetical scenario involved an asteroid at a distance of 35 million miles. Throughout each phase of the exercise that lasted a week, scientists received more and more data about the asteroid. They found out about the object's course, odds of hitting our planet, and its size, but they couldn't come up with a working solution to deflect it. Turns out we haven't yet invented spacecraft that could eliminate such a threat within 6 months. In fact, such a mission would take us 5 to 10 years. In the simulation, the asteroid would have landed on Eastern Europe. In fact, the only way to escape the big rock was to evacuate the impact area. And that's not helping us too much. But as we know, some things that don't work out in theory can show us good results in practice. So now, NASA plans to smash a spacecraft about the size of a refrigerator into the smaller Didymune asteroid that was mentioned earlier. The mission is called Double Asteroid Redirection Test, or DART. The idea is to take this half-ton spacecraft and crash it into Didymune around 4 miles per second. The launch will take place sometime between November the 24th, 2021 and February 15th, 2022. However, the collision should happen between September and October 2022. This is going to be the very first test using the kinetic impactor technique to alter an asteroid's trajectory and speed, and will be a kind of military training in terms of space. Now, Didymos doesn't threaten Earth yet, but NASA's database contains more than 2,000 potentially hazardous asteroids that can get as close to us as 0.05 astronomical units. Asteroids and comets are often hard to detect, even with the most advanced technology. But at times, people equipped with homemade telescopes make huge discoveries. Just 2 years ago, an amateur astronomer named Gennady Borisov stumbled across a celestial object with a peculiar trajectory. Turns out he found a comet, and not an ordinary one either. It was later discovered by scientists that 2I Borisov is a rogue comet. This is because this type of comet has no steady orbit and will freely float through space until affected by another celestial object. As astronomers continued to study 2I Borisov, they used NASA's Hubble Space Telescope and Atacama Large Millimeter Array, ALMA, to figure out the comet's extraordinary composition. It had an abundance of carbon monoxide they didn't expect to see. And knowing about this high concentration of carbon monoxide, scientists made assumptions about its origin. So far, astronomers have come to the conclusion it should have been created in a place overflowing with CO ice. Such an abundance of CO ice is only present in space regions with a temperature below -420 degrees Fahrenheit. There are two theories about how the comet formed. It could have been born around a red dwarf, a relatively small star with a low surface temperature. Otherwise, it could be a tiny fragment of a dwarf planet. This has become the first comet that entered our solar system from a place outside of our star's influence. But this is not the only thing that captured astronomers' attention. When approaching a star, a comet's particles start to melt and generate a fuzzy cloud around its nucleus. This cloud is called a coma. So what scientists noticed was a unique polarization in Borisov's dust grains. Now, polarization is the direction light waves ripple in space. The higher the polarization, the more focused the light is in a single direction. That's exactly what 2I Borisov's coma demonstrated. In the scientific community, this was a big deal. Similar to the way our skin reacts to direct sunlight, the more a comet interacts with a star, the bigger the impact on its materials. Eventually, the polarization of the comet's coma gets reduced. But what we see with Borisov's comet is quite the opposite. This can only mean one thing. It is rarely or never bathed in a star's light, radiation, or winds. So it's one of the most untouched and well-preserved comets we've ever detected. This leads us to the conclusion that the comet contains unaltered information about the materials that formed it in the first place, which could have happened some thousands, millions, or even billions of years ago. And since astronomers believe the birthplace of 2I Borisov partially resembles our solar system, that comet can reveal valuable information about another solar system much like ours. Borisov's comet already traveled past our sun in 2019. But this doesn't mean there aren't any other celestial objects about to visit us. We can only hope our telescopes will look in the right direction and at the right time so that we can prepare ourselves once they show up. We live on a perfectly functioning planet, but don't even think about how fragile our world is. Should you change one element and the entire system stops properly operating, the life that we're so used to would no longer be the same. If this happens, most living organisms on our planet would disappear. And all this is possible if our blue dot just stops spinning. But is this even possible? What would happen exactly? And how could this threaten humanity as a species? The Earth makes a revolution around the Sun once every year, or once in every 365.2425 days. But also, our planet rotates around its axis, making one revolution in 23 hours, 56 minutes, and 4 seconds. Let's start with the rotation around our star. Stopping this rotation would mean a definite death for all mankind. It's the force that keeps the Earth in orbit and holds back the mighty gravity of our star to keep us from falling into it. This is similar to how speed keeps a circus motorcyclist driving on the walls from falling. And if a driver hits the brakes, he would crash right down. So, in case our planet stops rotating, it would also rush towards the Sun. After a while, it would fall into the fiery ocean of the burning plasma. Just in a matter of seconds, Earth would evaporate and disintegrate into atoms. But how could this happen? The most painless scenario for us is an instant stop of rotation. The Earth revolves around the Sun at an orbital speed of around 107 kilometers per hour and travels at a distance of 2.6 million kilometers a day. So if our planet's rotation stops within a second, the Earth would experience an overload of more than 3000 G. Everything would instantly be destroyed and turned into dust. Suddenly, human beings would achieve a speed of 107,000 kilometers per hour, or almost 30 kilometers per second. The first cosmic velocity, or the speed at which the body becomes a satellite of our planet and does not fall on it, is roughly 7.9 kilometers per second. At that speed, unless you bump into something along the way, you become an astronaut and find yourself in orbit. But that's just the first cosmic velocity. The second cosmic velocity, or escape velocity, is 11.2 kilometers per second. At this speed, the body leaves the Earth forever. This is the speed that the Apollo spacecraft had to gain to reach the Moon. This fast, we'd all travel into the depths of space and revolve around the Sun in the form of space debris. The planet itself would not survive. Under the influence of such a monstrous overload, Earth would break into many pieces. Its core would be exposed and its magma would splash out right into the cosmos. The spectacle would be quite bewitching in its horror, but there'd be nobody to witness it. Still, this is the best scenario for us. What could be even worse? It would be a lot worse if the slowdown happens smoothly, without fatal overloads for the human body. In this case, the planet would rush towards the Sun along the ballistic curve. It would be reminiscent of a spacecraft deorbiting. As we approach our star, the temperature on the planet will constantly rise. At first, it will be hot, then very hot. Finally, it'll become unbearable. At a distance of about 70 million kilometers from the Sun, the temperature on the Earth's surface would exceed 212 Fahrenheit, but that's just the beginning. People that would stay in underground bunkers equipped with cooling systems would last the longest, but when the temperatures rise to 1,000 degrees, nobody would survive. Because of the enormous force of gravity at a distance of a couple of million kilometers from the Sun, our planet would be torn to pieces and collapse into a fiery ocean. Our star would become a global crematorium. This is the finale that awaits mankind if the Earth stops rotating around the Sun. But what would happen if our home stops rotating around its axis instead? If this happens quick enough, the results would be somewhat similar. Even though things wouldn't probably be turned into fine dust, they'd still be broken apart into fragments. At the equator, Earth's rotation speed is about 1,670 kilometers per hour, so the overload would be approximately 47 G. And as you go deeper or move towards the poles, the overload would increase. The planet itself is unlikely to collapse, but multiple earthquakes would occur in many parts of the world. For the Earth, such an event would be felt as a blow of a monstrous force. Because 1,670 kilometers per hour is only 0.46 kilometers per second, you wouldn't fly into orbit. At this speed, you'd be thrown along the course of the Earth's rotation in a western direction, and it's highly unlikely anyone would survive the landing. People who live closer to the North Pole, scientists in Antarctica and the Arctic would have the best chance of survival. No building can withstand 47 G, well, except for perhaps the Antarctic and Arctic stations where overloads wouldn't be so intense. In addition to earthquakes, severe tsunamis would take place all across the globe. This would be a lot more terrible than shown by any blockbuster. After all, the entire world ocean would begin to move. This is 1,338,000,000 cubic kilometers of water. There would be kilometer-high waves, so it's unlikely that even humans being close to the poles could survive. People on airplanes, the moment the Earth stops, would not survive either. All planes that were flying from east to west would sharply rush forward with an acceleration of 47 G, burst and crumble from such an overload. And planes that flew in a different direction would be dragged sharply to the west, either sideways or tail first, but all with the same outcome. Almost an instantaneous destruction. The only way humanity would have a chance of survival is if the deceleration of the Earth's rotation is slow. At a certain value of the deceleration, the friction force will even hold a person still instead of throwing it like a stone out of a catapult. If this is the case, many buildings would survive, and tsunamis wouldn't cause a global catastrophe. But as the dust from the destruction of some buildings settles, people thrown by a sharp push would rise from the ground. And it would then be the question of how to survive on a planet that isn't rotating. Stopping the Earth's orbital rotation is just an abstract assumption. But a gradual slowdown in the rotation of the planet around its axis is not just possible, it's happening right now. The Earth is constantly slowing down, and our days are becoming longer. Eventually, such a slowdown can result in a single Earth day lasting as long as one Earth year lasts today. That would mean a complete stop of rotation. Similar to the way our moon faces the Earth, our planet would have one side always facing the sun. We were only able to see the moon's reverse side on October the 7th, 1959, when the Soviet Luna 3 station photographed it. So, why is the rotation of our planet slowing down? The reason is tidal forces arising from the gravitational influence of one celestial body on another. One example of tidal forces is the ebbs and flows caused by the rotation of the Moon around the Earth. Under our satellite's gravitational influence, the points on the surface of our planet that are closer to the satellite are attracted stronger. As a result, there's deformation that can be easily spotted on the surface of the water. This is because, unlike solids, water molecules are less connected to each other. As the Moon pulls on different parts of the Earth, our planet's water bulges out on the side closest to our satellite and the side furthest from it. On a planetary scale, these forces may seem insignificant, but this isn't the case. There's a narrow and long bay in the Sea of Okhotsk, Russia. It's called Penzina Bay. The height of the tides there reaches 9 meters. And if the Earth, the Moon, and the Sun line up in a row, they grow to 12.9 meters high. These are the so-called spring tides. It's been calculated that if a power plant operating on the energy of these tides is built, its capacity would be 120 gigawatts. To compare, the United States has a total hydropower capacity of about 80 gigawatts, which is 1.5 times less. Such a power plant would be able to produce 1,054 terawatt-hours of energy per year, and all that would come from a single place on Earth. So where does this gigantic amount of energy from tidal forces go? Friction. Waves on our planet rise, fall, and beat against the shore. Now imagine a ball rotating on its axis that rubs against a wall. What happens to its rotation? It slows down. In the same way, Earth is gradually slowing down its rotation. Also, there are tides caused by the attraction of the Sun. Our star pulls the Earth 400 times stronger than the Moon. But the difference in the force of attraction between the surface of the ocean and at its bottom is less when it comes to the Sun. As a result, it creates weaker tidal forces, but they still exist. Every 100 years, a day on Earth lengthens by 1.5 to 2 milliseconds. In 200 million years, a full day will be 25 hours long. In 5 to 6 billion years, the Earth's rotation around the Sun and its own axis will match. Under such circumstances, the effect of the tidal forces would be minimal. This is because every system in the universe aims at achieving an absolute minimum of energy. The Earth is synchronized with the Moon in the same way, and it's not just our planet. All the satellites of the planets that are relatively close to them, like those near Mars, Saturn, or Jupiter, are synchronized. Our Sun has already synchronized Mercury. The same will happen to the Earth in about 5 to 6 billion years. And when it happens, there'll be a permanent day side and a night side on our planet. Those who temporarily reside in the Arctic Circle already experience a night for half of the year and then a day for the rest of the year, and they manage to operate just fine. But it's only a relatively small area of our planet. So what if this happens on a global scale? The heat balance of the planet will change. Strong winds would start blowing from the sunny, hotter half to the dark and colder half of the planet. On the night side, flora will have a very difficult time. Many plant species will perish. Only species that can exist with a minimum amount of light and heat would survive. Entire fields of wheat and other agricultural plants would be gone. There would be some moss and mold left. The same will happen with fauna. But you can't survive on moss and mold only. So at least for the several upcoming years, there will be hunger. But even this is not the worst. When the Earth rotates, centrifugal forces flatten it at the poles and create a hump at the equator. The diameter of the planet there is about 43 kilometers larger than it is at the poles. Without rotation, the hump would disappear and the oceans would float towards the poles. The Earth would have one giant continent and two oceans: Antarctica, Greenland, Canada, Siberia, entire Europe, a part of China, and half of New Zealand would go underwater. Along the equator, up to 30 degrees north and south latitude, plains and mountain ranges would appear. This would be a real disaster, with millions of victims. And even this is not the worst. As the Earth would significantly slow down its rotation from 24 hours to 365 days per revolution, its magnetic field, consisting mainly of liquid iron, would decrease as well. Flows would be formed in the Earth's core. They would rub against each other and become electrified, forming loop currents. As a result, a system of currents would circulate along a conducting circuit which would induce a magnetic field that encircles our planet. The northern lights are a visible result of this process. We could easily live without the magnificent northern lights, but not without the protection against solar radiation. Our magnetic field, weakened by 365 times, wouldn't save us. So those lucky enough to escape being covered by tsunamis, flooded during the formation of new oceans and continents, and those surviving the hunger would still have to live inside underground caves where radiation cannot reach. Still, even inside caves, there wouldn't be many places suitable for survival. People would only be able to live in tiny areas on the border between day and night sides. Depending on the hemisphere, there'd be eternal dawn or sunset. And it wouldn't be possible for all human beings to settle down along the entire favorable line. This is because a large part of the land would be flooded with oceans, and you'd have to choose an area with an optimal atmospheric pressure and temperature. Our descendants would probably know for sure whether life is possible on a planet that's always facing its star on one side. There are several planets orbiting the star TRAPPIST-1, located on the constellation of Aquarius. This is just 39.5 light-years from the Sun. This planetary system was discovered in 2017. In total, 7 planets have been detected so far, 3 of which are in the habitable zone. All 3 of them are approximately the same size as the Earth and are also rocky. At the same time, they have average temperatures of 15, -22, and -54 degrees Celsius. The star itself is a red dwarf with a diameter of only 1.1 times the diameter of Jupiter. TRAPPIST-1 only emits 0.05% of the energy emitted by the Sun. All the planets there are located very close to the star. The 3 planets in the habitable zone make a revolution around their star in 4.6 and 9 days. The periods of revolution of these planets are identical and are in resonance with each other. So these planets are tidally locked, meaning they face their star on one side. Hopefully in a couple of centuries, humanity masters their technology and flies to the stars to find out if life is possible on these planets. The famous doomsday clock shows 100 seconds before the apocalypse, and it won't happen because of some higher power, but upon the initiative of a human being. We've never come so close to the edge of the abyss. Nuclear war. One more step, and the history of mankind is over. And unfortunately, current world problems, personal ambitions of some politicians, and a lack of desire to seek compromises between governments can make this last fatal step real. And then, the Earth will face the Third World Nuclear War, in which there will be no winners. Imagine that someone pressed the red button and nuclear missiles got in the air. We will show you that humanity would stand no chance. To understand what nuclear war means, let's take a look at the power of nuclear weapons and their stockpiles in different countries. There are two different types of genres of nuclear weapons. Strategic nuclear weapons are the big ones that are pointed at certain targets and are launched on intercontinental ballistic missiles and submarine and cruise missiles. Tactical nuclear weapons are non-strategic and are used in smaller, more mobile applications. They work based on the fission of uranium or plutonium nuclei and are generally smaller in explosive power. These types of weapons include gravity bombs, short-range missiles, artillery shells, depth charges, landmines, and some small torpedoes. At the same time, the fusion of deuterium and tritium releases 10 times more energy. So thermonuclear bombs are much more powerful than uranium or plutonium bombs. What's even more frightening is that there's no theoretical limit to the size and yield of a thermonuclear weapon. In 1961, in the USSR, a thermonuclear bomb with a capacity of 58 megatons was detonated on Novaya Zemlya. The power of the explosion was equivalent to the explosion of 58 million tons of trinitrotoluene, or TNT. Imagine 580,000 cargo rail cars filled with TNT, all blown up simultaneously. And initially, it had to be a 100 megaton bomb. But even 58 megatons is still 10 times more powerful than all the weapons, including bombs and mines, used during World War II. So what amounts of such a deadly weapon does humanity have at the moment? More than enough. The nuclear club is a term used for the group of nations who possess thermonuclear weapons, and the leaders of this club are Russia and the United States. About 90% of all nuclear warheads are owned by these two countries. Russia has 5,977 nuclear warheads, and the US owns a total of 5,428 warheads in its military stockpiles. You can see the distribution of deadly weapons among other countries on the screen. For humanity, the situation doesn't look good. All countries that have nuclear weapons either increase their supply or leave it as it is. The only exception is the United States, and the figures only show the number of nuclear warheads intended for use atop strategic carriers with a range of several thousand kilometers. But there are also tactical nuclear munitions of small power, the TNT equivalent of which doesn't exceed a few kilotons and is often less than 1 kiloton. But this is still a lot. By modern standards, the atomic bomb that was dropped on Hiroshima and destroyed the city can be considered a tactical nuclear weapon. Its power was no more than 15 kilotons. To compare, the Russian SS-18 Satan intercontinental ballistic missile has 10 thermonuclear warheads on board, each with a capacity of 800 kilotons. So one such warhead is 53 times more destructive than that dropped on Hiroshima. This means that one Russian missile is 530 times more deadly than the first atomic bomb. The Russians have 46 such missiles as of 2022. Besides, Russia has already developed and tested the new RS-28 Sarmat missile that will replace the Satan, and it has to be even more effective. Aside from this, they also have Topol and Yars missiles. A total of 320 missiles are located in mines or on land vehicles. Plus, there are 176 missiles on Russian nuclear submarines of the Bore, Delphin, Akula, and Kalmar classes. But that's not all. Russia has 68 strategic bombers, the Tu-95 Bear and the Tu-160, also known as the White Swan, which all carry a total of 580 nuclear cruise missiles. Hopefully it doesn't turn out to be a black swan for humanity. The United States has just about the same deadly arsenal, and now imagine that all this will be used against humanity. So how can a nuclear war begin, and how will it happen? Mankind has not experienced global horror like that during the Second World War for more than 70 years. Most of those who remembered the bombings and the fear that filled a person when everything around collapsed and burned aren't here anymore. These were times when there was no hope for even the slightest bit of medical care, and when people had to starve for weeks, months, or even years. And to keep warm, they had to burn their furniture and books. Modern people have only seen a nuclear war in computer games. Unfortunately, even some politicians don't understand all possible consequences, and this only increases the risk of nuclear conflict. This is also facilitated by the modern missile defense systems that the leading nuclear powers have. The Russian and American political elites attempted to destroy their main geopolitical enemy with a single missile strike and avoid counterattack by hiding behind a missile defense umbrella. Here, for example, is the Russian A-135 anti-missile system. It consists of a huge four-sided pyramid with a height of 33 to 35 meters, a side length of 130 to 144 meters at the base, and 90 to 100 meters along the roof. This is the Don-2N radar station that consists of 2 command and control centers and up to 100 anti-missiles of long-range and short-range interception. All of them are equipped with nuclear warheads with a yield of up to 1.4 megatons. That is almost 5 times more powerful than the Satan warhead. The United States has a similar system that consists of several components. First of all, this is the ground-based mid-course defense system designed to intercept ballistic missiles with 44 anti-missiles. Also, the missile defense system includes the Aegis ballistic missile defense system that operates on warships. It's designed to destroy small and medium-range ballistic missiles. The third component is the THAAD mobile complex that provides advanced cover for military bases and strategic facilities from small and medium-range ballistic missile warheads entering the atmosphere. The capabilities of the complex don't allow it to hit targets in outer space, though. Both the Russians and the Americans have anti-missile defenses that can destroy up to several dozen enemy missiles, but not hundreds, so a massive nuclear strike could break through this defense. Computer simulations show that if Russia detonates even 300 of its strategic warheads over the US metropolitan areas, there'll be about 78 million fatalities in the first half hour. In addition, the entire economic infrastructure of the country will be destroyed. The electricity grid, the internet, the food distribution system, the transport network, and the healthcare system. Everything necessary to sustain normal life will disappear. And within a few months after the attack, the vast majority of the US population will fall victim to starvation, radiation sickness, and epidemic diseases. The US attack on Russia has similar consequences, and if NATO is involved, the same fate would await most of Canada and Europe. Let's take a look in more detail at the consequences of a strike on New York, with just one Russian thermonuclear warhead that has a yield of 800 kilotons. Remember, the Russian Satan has 10 of them. Let's say the epicenter of the explosion was in Manhattan, in the center of Times Square. During the first second, a fireball with a radius of 1.15 kilometers will cover an area of 4.15 kilometers squared. Everything inside the fireball will instantly evaporate. And by looking at this photo taken in Hiroshima, you can see what would happen to people. This isn't a drawing. It's a photo of all that's left of an old man with a cane. The nuclear blast from the Hiroshima bomb was so powerful that objects and people in its path left behind black shadows. The intense heat and light bleached the concrete around the shadow, but people who would find themselves in this fiery circle would be still lucky. They would perish without feeling any pain. It would happen faster than electrical signals travel through the nerves to the brain. Following the light wave, there'll be a supersonic shock wave. Within a radius of 2.02 kilometers or an area of 12.8 kilometers squared, the overpressure will be 20 pounds per square inch. Under such pressure, heavy concrete buildings are seriously damaged or destroyed, and the mortality rate is nearly 100%. In a radius of 4.71 kilometers or an area of 69.6 kilometers squared, the overpressure will be 5 pounds per square inch. This pressure is enough to collapse most buildings. The height of the layer of debris will reach 10 meters, burying tens of thousands of unfortunate people under it. So, passing away immediately will be huge luck. There'll be fires in many places too. Then people within a radius of 9.7 kilometers or an area of 296 kilometers squared will receive burns of the third degree from thermal radiation. In a radius of 10.9 kilometers, an area of 375 kilometers squared, damage to the lungs from overpressure will occur. And let's not forget about the invisible and silent killer, radiation. Within a radius of 2.43 kilometers, an area of 18.6 square kilometers, the dose of ionizing radiation will be at least 500 rem. Such a dose is fatal within 1 month in 50% of people, and 15% of survivors will eventually pass away from cancer. The total estimated number of fatalities in New York will be almost 1.8 million people, and the number of those with burns, injured, and heavily irradiated would reach over 2.8 million people. However, Satan may not have 10 warheads of 800 kilotons each, but one super thermonuclear warhead with a capacity of 25 megatons. If this thing explodes over New York, almost 5 million people will be gone. The fireball will have a diameter of almost 10 kilometers. This will also create a zone of continuous destruction with a pressure of more than 5 pounds per square inch and a diameter of 27 kilometers. The diameter of the thermal lesion, burns of the third degree and above, would be 82 kilometers. But again, this is what would happen in case of a single strike. If the Russians decide to launch all their nuclear missiles, then the United States will cease to exist, and the same would happen to Russia. But what about the other regions that wouldn't be affected by a direct nuclear attack? Would life be possible there? First, background radiation will significantly increase due to the explosions of thousands of thermonuclear warheads. nuclear power plants will make a big contribution too. After all, about 440 nuclear power reactors are currently operating on the planet, and this is thousands of tons of highly enriched uranium. The explosion of just one such reactor at the Chernobyl nuclear power plant in Ukraine made an area of 2,600 square kilometers uninhabitable. And now multiply this figure by 440. This is about 1,150,000 kilometers squared, and these infected zones won't be located in any remote places but near large cities. But then, a war involving the entire US and Russian arsenals could release up to 150 teragrams or 150 million metric tons of soot into the upper atmosphere, bringing global average temperatures down to -8 degrees Celsius. In North America and Eurasia, temperatures will drop by 45 to 50 degrees Celsius, the levels not seen since the last ice age. And this will lead to a catastrophic reduction in food production and starvation that could wipe out most of humanity. In addition, there'll be no electricity. All power plants will be destroyed. No gasoline and no diesel fuel. Oil refineries will be ruined. And if Russians hit the Yellowstone supervolcano with some kind of large thermonuclear bomb, it would provoke its eruption. This alone, without other nuclear strikes, can become a disaster for the United States, because it would suffer most from such an impact. On the spot where once was the national park, there would be a huge hole, and extreme volumes of ash would fall on North America. Volcanologist Robin George Andrews believes that this would lead to problems with agriculture. The ash would clog engines, disable power lines, and pollute the water supply. According to his colleague, professor at the University of Cambridge, Clive Oppenheimer, the atmosphere would be filled with such thick ash that a volcanic winter could begin. If this happens, sulfur dioxide will block the sunlight, the continent will freeze and plunge into darkness, and this is not to mention Russian Poseidon nuclear torpedoes. In case of a nuclear war, these will be sent to the west and east coasts of the United States and, when exploded, form a tsunami that would hit the country's coastal infrastructure. Also, some nuclear strikes would be aimed at industrial, scientific, and administrative centers. Almost the entire industrial and scientific potential would be destroyed. In other words, survivors would find themselves in the Middle Ages. And even people lucky enough to survive would be plagued by diseases caused by high radiation background levels. As a result, barely any healthy offspring will be born. So, people who expect to survive a nuclear apocalypse on some tropical islands or in Siberia are deluded. Their life will turn into a struggle for survival. So within one, at most 2 generations or 50 years, humanity would either disappear completely or at least the world population would significantly decrease in number. Whatever the case, this would mean the end of modern civilization. The only chance of survival and long life would be given to those who started the nuclear horror, the political leaders of Russia, the United States, and some other countries. They've already prepared special bunkers located hundreds of meters underground with everything necessary for life. But this, of course, will only help if they manage to hide there in time. The bunkers are designed to withstand a direct hit from a nuclear weapon. According to a report made by the US Department of Defense Intelligence Service, Vladimir Putin has 2 huge bunkers. The political elite of Russia should hide in these super secure structures if a nuclear war breaks out. Pentagon experts say the 2 bunkers can hold up to 10,000 people in total. One of these huge bunkers, at a depth of 300 meters, is located under the Kremlin, and another one isn't far from Lomonosov Moscow State University. The bunkers store supplies of food, fuel, oxygen, communications equipment, first aid posts, and other systems necessary to support life. People there can live for several months after a nuclear attack. Another important object, according to the American press, is allegedly located in the Ural Mountains. This is the legendary mountain Yamantar. Beneath it, there's a secret underground bunker, or more precisely, an entire city. Experts say it's designed for the simultaneous residence of 300,000 people. To compare, this is just about the population of Pittsburgh or Anchorage. In this underground complex, which is divided into so-called houses, all the necessary infrastructure has been created, communications have been connected, and life support systems have been established. It has all the conditions for people to stay in this underground city for at least 6 months without coming out to the surface. A similar infrastructure exists in the United States, but just on a smaller scale. So would this handful of people be able to revive humanity? Of course not. Almost all the knowledge gained by people throughout thousands of years of history will sink into oblivion. Nuclear war means the end of the current human history. Humanity will either perish within 1 or 2 generations, or be thrown back centuries. There will be no winners in a nuclear war. We must clearly understand this and realize that we've come too close to the edge of the abyss. What do you think about this? Can we prevent taking this last fatal step? Tell us your thoughts in the comments, and don't forget to subscribe to our channel so you don't miss out on other videos about the most important problems that humanity needs to solve. There are millions of asteroids floating in our solar system. Every year, thousands of meteorites weighing about a pound fall on Earth. Usually we don't see them because they land in uninhabited forests or the ocean. However, in 2004, scientists discovered a really dangerous asteroid in space, weighing more than 20 million tons. The first observations show it has a 2.7 chance of hitting us in 2029. If an asteroid this big hit the Earth, it would cause major devastation over the area it impacted. But what is the real chance of it hitting us? And what can we do to prevent big asteroids from hitting our planet in the future? Apophis was first discovered on June 19, 2004 by astronomers in Tucson, Arizona. The asteroid measures about 1,100 feet across, about the size of 3.5 American football fields. It raised alarms because initial calculations had shown there was a good possibility it could smack into the Earth April 13, 2029. Since its discovery, optical and radar telescopes have been tracking Apophis as it orbits the Sun, and scientists are mostly confident they know where it's headed. Current calculations show it will come really close to the Earth at around 19,800 miles from our planet's surface in 2029. That's close enough to come between the Earth and the Moon, which floats around us at about 238,855 miles away. The path the big asteroid is taking is within the distance of some satellites, and that sounds too close. But what if something affected the orbit path of Apophis, which is very possible, and this asteroid smashed into our planet? It's a well-known fact that an asteroid impact is one of the things that can cause global mass extinction, especially if this asteroid is large enough. Physicists like the late great Dr. Stephen Hawking said that an asteroid collision is the biggest threat to all life on the planet. If an asteroid like Apophis was to hit the Earth, the impact would unleash a blast equivalent to over 1 billion tons of TNT. In comparison, the recent explosion in Lebanon, Beirut, of approximately 2,750 tons of ammonium nitrate caused an explosion equivalent to 1 kiloton of TNT and took the lives of over 200 people. Thus, an asteroid impact by Apophis directly over a populated area would not only result in the deaths of millions of people, but would also have a terrifying and lasting impact on the ecosystem of our planet. Although it may not be an extinction-level event, it would forever change our biosphere and affect human civilization for centuries to come. Asteroids were crucial in the formation of planets in our solar system. Major impact events have significantly shaped our Earth's history and have been associated with the formation of the Earth-Moon system, the evolutionary history of life on our planet, the origin of water, and several mass extinctions. On other planets in the solar system, asteroid impacts have resulted in various phenomena. The two distinctly different hemispheres on Mars are because of asteroid impacts some 3.9 billion years ago, and the unusual spin of Uranus was confirmed to be caused by a collision with a massive object twice the size of Earth. It's very rare for an asteroid the size of Apophis to pass so close to Earth, although smaller asteroids in the range of 16 to 33 feet in size have been observed passing by at similar distances. These type of asteroids are classed as near-Earth objects, or NEOs, and these objects and their orbits are constantly tracked by astronomers around the world. NASA uses Earth Impact Monitoring System to automatically track and scan asteroids that will probably hit us within the next 100 years. NEOs have become an increased interest since 1994, when big pieces of the Shoemaker-Levy 9 comet slammed into Jupiter after being torn up by its gravity. Scientists got to see it in real time, as Earth telescopes were recording it. This event highlighted the potential danger of NEOs. As of January 2019, 19,470 NEOs have been discovered. Only 107 of them are comets that are largely made up of ice and rock, while 19,363 of them are asteroids. These asteroids are classified into different categories based on their orbits and the danger they pose to Earth. So far, there are 4 orbit classifications. Amor class are types of asteroids whose orbits do not cross Earth's orbit around the Sun, thus posing no threat to us. The Apollo class of asteroids are Earth-crossing, whose orbits are greater than that of the Earth. Their perihelion, which is the nearest point to the Earth, is less than 1.017 astronomical units. 1 AU is roughly the distance between the Earth and the Sun, 150 million kilometers or 92.9 million miles. The 2013 Chelyabinsk meteor that exploded over the city of Chelyabinsk in the southern Urals region of Russia was an Apollo-class asteroid. As of December 2018, the number of known Apollo asteroids is 10,485, making the class the largest group of near-Earth objects. Aten's class of asteroids are Earth-crossing and are a dynamic group of asteroids whose orbits bring them into close proximity with Earth. Their orbits are smaller than the Earth's orbit around the Sun, or less than 1 AU. This makes them potentially hazardous objects, or PHOs. As of 2019, 1,490 Atens have been discovered, of which 12 are named. Apophis is an Aten-class asteroid that completes an orbit around the Sun in a bit less than 1 Earth year. After its close encounter with the Earth in 2029, the orbit of Apophis will be widened to become slightly larger than the width of Earth's orbit. At this point, it'll be reclassified from the Atom group to the Apollo group. Finally, there is the Atira class of asteroids, whose orbits are strictly inside the Earth's orbit and are no immediate threat as of now. However, their orbits can be altered because of the gravitational effects of the inner planets of our solar system like Mercury and Venus, which could make these Earth orbit crossing asteroids in the future. Based on these classifications, scientists have also come up with scales to measure the impact hazards of asteroids. Scientists now believe that there is no danger of Apophis hitting us in April 2029. But space by its nature is unpredictable, and despite our best efforts, if tomorrow scientists discover an asteroid heading towards us, given our current technologies, there's really very little we can do. The only thing that will help us is time. The earlier we spot such objects, the more our chances of survival increases. Today, it's estimated that it would require us to have over a decade of planning to significantly alter the path of an asteroid's trajectory, or to minimize the effects of a potential impact. That's why searching for NEOs and tracking them have become such an important mission for space agencies around the world. This lack of human capability has also given rise to a new field of study known as asteroid impact avoidance. In recent years, many agencies around the globe have concentrated resources and funding towards future missions that aim to change an asteroid's trajectory. Since then, many scientists and engineers have proposed various ways to attempt this. Some have suggested we strap rocket engines to the rock that threatens us and push it away. Others have suggested that we use nuclear weapons to kick an asteroid from its orbit, or even shatter it into smaller bits. These ideas have led to ongoing missions such as the Double Asteroid Redirection Test, or DART, which is a collaboration between NASA and ESA to test the hypotheses of impacting a spacecraft into an asteroid to bring about a change in its trajectory. These days, scientists study asteroids' trajectory, size, shape, composition, and even their interior. All this research will provide humanity with the required knowledge to develop impact avoidance technology. Apophis flying so close to the surface of Earth in 2029 is such an incredible opportunity for science. The asteroid will be in range to be observed with both optical and radar telescopes. Radar observations could possibly provide surface details that are only a few feet in size. There are currently many missions being planned to make full use of this rare opportunity. That being said, there is still a small probability that Apophis has a chance of impacting Earth. In its close encounter with Earth, Apophis would pass through a gravitational keyhole, a small region no more than about a half a mile, 0.8 kilometers in diameter, that could set up a future impact exactly 7 years later in 2036. But the chances of that are said to be less than 1 in 100,000. This gives the asteroid an impact hazard of level 1 on the Torino scale. So despite its close approach, you'll not have to spend sleepless nights wondering whether it'll hit Earth or not. That's all we have for you today. If you want to know more about other asteroids, then check out our video about an asteroid that's projected to fly past Earth 10 times closer than Apophis this year. The link is in the description below. We create informative videos that keep up with current space news. So make sure to subscribe to our channel, hit that notification bell, and give us a like if you enjoyed this. And let us know if you have an awesome idea for changing the trajectory of an asteroid that could threaten our planet by commenting below. Thanks for watching.